Alright, so now we're going to talk about characters and strings, which are necessary ingredients for outputting any kind of text. And we've already had strings all over the place. This is a string and this is a string. And if you're used to Java, you're used to both characters and strings. So let's take a look at what you can do with them. So first of all, I'm going to declare a character. Now that would be of type char. Some people pronounce it car, but I think it's still char. And I'm going to give it a value of x with single quotes, just like in Java. Now, obviously, the char type is redundant because you can pretty much infer the type from the assignment. However, what you can also do, you can put Unicode in here, so I can do 0041, for example. What you cannot do, though, is, oh, sorry, too many letters. What you cannot do is you cannot treat it as an integer and start comparing it to integers, that sort of thing. So, for example, if I write something like, if a is equal to 65, then print line match. I cannot do this because it's not an int. However, there are plenty of conversion functions for doing exactly that. So instead, what I can say is I can say a dot to int, and this makes it all right. So I essentially take my character, but then I convert it to an int, compare it with an int, and that's going to be just fine. All right, so what else can we do? Well, characters aren't very exciting. However, we can start talking about strings, and we've already seen very simple strings. So for example, if I make val b, or indeed var b, as a string with a value of hello. By the way, strings are still immutable, so I'm not sure what I'm actually doing here. Let's have a val instead. So I can certainly print out this string, or I can print out, for example, the first character of this string, or I can go ahead and use a for loop, for example, to iterate over every single letter in the string and print it on its own line, for example. So I can say for letter in B, I can print line the letter. So let's run these examples, see what we actually get. All right, so first of all, I did in fact print out match because this Unicode character is in fact equal to 65 if you convert it from hexadecimal. So we printed a match here. For the string, we simply printed the string. The first character is a H, you can see it here. And then we printed each of the characters on its own line. All right, so nothing particularly magical about this. Now, Kotlin also supports raw strings, and raw strings basically means that you put a delimiter, and then until the closing delimiter, you can basically have anything inside that string, including things like line breaks, for example. So let's have a raw string. You put a triple double quote, and after this, anything goes. So essentially, you can say hello, and then you can do a line break right to the start of the line. You can put test in double quotes, for example, which is something you cannot do in an ordinary string without escapement. And here I can say world, and then I can put in a triple double quote here to sort of finalize the string. So here's my string, and then I can print line this raw string. I pressed debug instead of run. Let's see what this does. Probably exactly the same thing because I haven't got any breakpoints in here. So here is the output. You can see that the line breaks here were basically taken from the actual source file. Okay, so what else can we do with strings? Well, we can interpolate them. And we've already seen this a little bit when we did some of the other examples. Let me just dig up. Like here, for example, when we were putting the value of the variable a right inside the string, we used $. So let's solidify our knowledge of this approach. So essentially, what you can do is you can say, for example, val c equals 123.0. You can say val d equals, and this would be a string which has the value of c. So you put $C. You actually notice that there is code completion here. Once you type the dollar, you can sort of get code completion as soon as you start typing things here. Okay, so this is easy if you just want to take a variable and output it. However, if you want an expression of some kind, then you can get that as well. And for that, we just have $, with the curly braces. So for example, I can say price is equal to, and then c divided by 10, for example. So c divided by 10 is an expression that will return a double, which is 12.3, and then we output that. For that, we use the $, with the curly braces. One question you might have is, what if I want to output $? And in this case, you have to make an expression which returns $, as a character, so like this. I know it's a bit clumsy, but you know this works. So price is equal to, and we'll see the value in just a moment. Let's run this. All right, so Interesting. Okay, yeah, we forgot to actually print. So print line, the value of D. Go again. Okay, so here it is. C is equal to 123.0. The price is then the dollar sign, as we made it in this weird fashion, and then 12.3 is the result of dividing 123 by 10. That's what we printed. And strictly speaking, you can get really crazy with the expressions here, because anything that is an expression can go in here. So let me give you let's try the most weird example that one can think of. So I'm going to have a dollar with curly braces, and inside I can have, let's have a range, 10 down to 1, and then we'll have it converted to a list, for example, and then we can map it to, what shall we map it to? Well, I can do a toString on it, and then change it to a chart list, like so, and then we can join it to a string, but with the ordinary call here. Okay, so we can try printing this out and seeing what this gives us. Should be interesting. All right, so as you can see, what happened is we basically took 10 down to 1, decomposed them into characters, and made arrays out of that, and put it all into a big sequence. So this is just goes to show that inside of these interpolation expressions, you can have virtually anything so long as it returns a value that you can actually print.